So this is the circuit question, and there is an input pulse, and we have to plot the output waveform. So I am considering around some time frame, like at t is equals to 0 time frame, t is equals to t is equal less than t on and greater than 0 time frame, t is equals to t on time frame, and t greater less than t less than greater than t on time frame. And this is t full length is t on t time period. This is t on time period. So let's take let's take t is equals to 0 time frame. At t is equal to 0 time frame, we have to understand that this is t is equal to 0 time frame, where the input frequency is infinite. Like this will behave as an infinite frequency response, in infinite frequency input. So due to this, the circuit will behave like this. This is a capacitor, this is resistor, this is again an capacitor, and this is V out, this is V in. So many will think like zero voltage appears here, or some will think input voltage appears here, but it's not true. There is this node, at this node, at any node, only one voltage will appear. There is no two voltage, and no two voltage can't be possible. So circuit will look like this. We can assume this. Why this is solved? Like for its infinite frequency response, capacitor's impedance, cap impedance, becomes zero because it's 1 upon SC. S is in frequency. If frequency is infinite, impedance is zero. So capacitor will short for this circuit. Capacitor will short this circuit. Capacitor will short. So this point will short. This point will short, and we can think this circuit like this. Now if there is two voltage appear on the node, then we can assume the circuit like this. Their impedance is nearly zero. It look like this, and it will become an capacitive divided circuit because this R and this capacitor are in parallel. So smaller impedance wins dominate. So this capacitance will consider, and it will look like an capacitor divided circuit. C1 and C2 both are equal, so so input voltage choke by half. Input voltage will reduce by half factor. So V out become V in by 2. It's a capacitor divided circuit, so the input divided by half, and the capacitance are equal. Okay, so the output at V out is V in by 2. It is equals to 0 time frame, and when and this is t is equal to 0 time frame, V out is V in by 2, which is 2.5 volt. Now this time frame is done, and when we go to this time frame 0 to t on time frame, like 0 to t on time frame, this is that we can see. We draw the circuit. If we draw the circuit, then there is a resistance, and this is V out. There is 2.5 volt plus 2.5 volt. This will satisfy the KVL, because 2.5 gives us 5 volt, which is equal to V in. So when the time period proceed from 0 to t on, then this capacitor starts start discharging from this resistor, because these are in parallel. So this capacitor sees this resistance and start discharging, because no current is flowing there. I will explain later why is this happening. So this capacitance starts start discharging. Okay, at this point we can see the V out start reducing from 2.5 volt to 0 volt. So this node will go down, and there is the input which is of 5 volt. So we can see and voltage difference between this node to this node are start increasing. So and then current a current will start flowing through this branch and go to this resistor like this, and due to this capacitor starts charging. So we see 2 start rising from 2.5 volt to 5 volt because the input is 5 volt, so maximum voltage can be reached is 5 volts. And we can also see like if uh, and this is kind of an steady state. This is kind of a steady state. In steady state, capacitance become open circuit. So if we open this circuit, and this is also open circuit, so and this is Vn, and we can see all Vn drop across this C1 resistor. So Vc1 will become Vc1. So Vc1 become 5 volts because all voltage drop will occur at this capacitor. So we prove this by intuitively. So Vin will Vout will reach to 0 volt and Vc1 from 2.5 volt to 5 volt in this 0 to t on time period. Okay, so we finish this t on t this time period, and if we consider at t is equals to t on time frame, t is equals to t on time frame, the circuit is look like this. Uh, this is 5 volt. This is 0 volt. So when when pulse reaches to this time period, we can see V out is 0. But at the other hand, the input changes to 0 volt. Input changes to 0 volt. That this is a 0 volt time frame. So circuit look like this. This is capacitor C1. This is C2 capacitor. This is resistance, and this is V out. And there is an 5 volt, and there is no resistance between these two capacitors. So instant charge sharing occur. Instant charge sharing occur. These capacitors are equal. So equal voltage is appear on the both on both capacitor. So 2.5 volt appear to this capacitor, and 2.5 volt appears to this capacitor. This is charge sharing property of the capacitance. So at t on, instantly when the V output reaches to 0 volt. So this is plus, this is minus, this is 5 volt. So it will convert it into plus minus 2.5 volt, plus minus 2.5 volt. This is resistor, this is V out. Okay, and we can, if we go by the negative sign convention, then V out is minus 2.5 volt. So instantly when it will reaches to 0, the output goes to minus 2.5 volt. And if we see time frame t less than t time frame, greater than t on time frame, and we see the circuit, this is circuit, this is a this is resistance, this is V out. We can see an 2.5 volt plus minus 2.5 volt. I am showing the minus so you can take the reference. And from this to this time frame, the capacitor shows these two capacitor see the resistance in parallel. So it will start discharging. through this resistor. So eventually V out will become 0 from minus 2.5 volt 0 volt. So uh, eventually a capacitor discharge and reaches to zero state, and overall circuit reaches to initial state. And now again cycle continues with another pulse, another time period, another pulse. So if I make a graph of waveform, it's an input. This is t1 time period. This is t time period. This is v. This is time. And if I plot the output waveform, so we find out at t is equal to 0. T is equal to 0, V out reaches to 2.5 volt. So it will reach to 2.5 volt, and it starts decreasing, and it decrease exponentially because there is a resistance between the ground and the capacitors. It will start decreasing exponentially, and then again when it reaches to TO, V out reaches to 0 volt, but instantly it will again rise to minus 2.5 volt, minus 2.5 volt, and then it start decreasing, eventually reaches to 0, and then cycle repeats, and we get this waveform. So this is the input waveform. Hope you like it, the solution. So now we can perform the simulation for the circuit, and let me connect my mouse. Now we can verify the output we are achieving when we are achieving by calculation or theoretical explanation. Now we can verify this in simulation. So first of all, add capacitors. Just uh, rotate this capacitor, Control plus R. Then click. Then again rotate this capacitors, Control plus R. If you want resistors, just press R. And if you want a voltage source, just press V. Now connect all the circuit. Connect all the circuit, and this connect to this, connect, and if you want to if you want ground, press G and connect ground, uh, and now allot the values to the capacitance, and allot the value to the elements. Capacitor is 20 nanofarad. Enter. Again, this is also in 20 nanofarad. Okay. This is 5k resistance, 5k resistance. Okay. And the voltage source is pulse, but this is a DC value, DC voltage, but you have to go to the advanced section, then click the pulse and make the initial voltage 0. V out is 5 volt. Make delay is 0. T is also 1 nanosecond. 1 nanosecond. Make it practical. So I'm assuming rise and fall time is 1 nanosecond. 1 nanosecond. Then T on time. Uh, this is an important part. The T on time is like our pulse time period is 10 microsecond, means 1 millisecond. So this is in half. So means half millisecond, and we can allot this is as 10 microsecond. Sorry, 5 microsecond. 5 microsecond is half millisecond, and the total time period is 10 microseconds, and we will run this for 3 milliseconds and number of cycles. No, okay, no. What number of cycles we want? We want 10 number of cycles. This is good for our simulation. Then we will run, and how how much time, what time we कितने टाइम के लिए हमें रन करना है? 3 milliseconds. And then click press simulate. Click on first input waveform. Okay, what is this happening? Oh, sorry, so maybe there is some error. 5 plotted like this, 0.0005 millisecond. Then um, time period is 0.001. Okay, now run again. Yes, there is a good looking uh, pulse waveform which is 0 to 5 volt. This, okay, and this is an input waveform. When we click on this, this input of pulse is appearing, and when we click this output pulse, then we can see our verified waveform. Like it's our input waveform. This is input, and this is our output waveform where 0 volt to 2.5 volt is initially appearing to t is equal to 0. Then it start decreasing, decrease, and attain 0 volt, nearly 0 volt, and then again it rises to minus 2.5 volt. Why it's not completely discharged? You are thinking, because uh, it will just reach to this point, and it's not completely discharged. So it's depend upon uh, time constant. When you calculate the time constant of that circuit, in this circuit, then we get the time constant of time constant of we get a time constant of 200 microsecond, and we see the wave of our input pulse with which has time period of 10 microseconds. So our time constant is greater than time pulse waveform. That's why capacitors are not fully charged and not fully discharged. That's why we are seeing some positive value here, and then minus 2.5 volt, and then start discharging again like this, and the cycle repeats.